Okay, hi everyone. So, this is now the continuation of our lesson on the roots of quadratic equation. So, for today's lesson, we are going to determine the nature of roots of its equation. And we know that the discriminant is equal to b squared minus 4ac. So, let's start now. If we have the first example, so determine the nature of roots of its equation if we have x squared minus 6x plus 9 is equal to 0. Okay. So, and we know that the discriminant is equal to b squared minus 4ac. So first you're going to determine the value or identify the values of a, b, and c. Since your equation is in the standard form, we can easily get the value of a, and we know that a is equal here to 1, b is equal to negative 6, and c is equal to 9. And after identifying the values of a, b, and c, we are now going to substitute it to the equation that b is equal to negative 6. Then you're going to square this one, minus 4 times your a is 1 times 9. And simplifying this, we have negative 6 squared is 36 minus 36 is equal to 0. So, the discriminant is equal to 0. And the roots of this, since it's equal to 0, is real and unequal. Okay? So the roots are, the nature of roots are, so we have real, equal, and rational. Okay, so we will check if they are real, equal, and rational by getting the roots of this equation. So if we have x squared minus 6x plus 9 is equal to 0. So therefore, we are now going to use the methods of finding the solutions of a rational expression. So we can use factoring, completing the square, and by quadratic formula. So we are going to use the easiest, which is factoring. So factor is equal to 0. So factor by x squared. Since this is positive, so this is negative. So the factor of 9 is 3. So therefore, we are going to check negative 3 times negative 3 is positive 9. Negative 3 and negative 3 is equal to negative 6. So therefore, the roots are negative 3 is equal to 0. And the roots now is equal to 3. Also here, x minus 3 is equal to 0. So the same, we're going to transpose. So therefore, we have, these are now the roots of this equation. So the nature of roots, since the discriminant we get the discriminant which is equal to 0. And this tells us that the roots are real. Yes, it's a real number. So 3 and 3 are real numbers. Check. Okay? And they are equal. So since the roots are 3 and 3 and 3, so they are equal. Check. And they are rational. So, rational numbers sila. So, therefore, so check. So, this is the roots and the discriminant. So, the real, equal, and rational. Okay, so we have another example. If we have x squared plus 6x plus 5 is equal to 0, then identify A is 1, B is 6, C is equal to 5. Then find the discriminant, B squared minus 4AC. Then substitute the value of B is 6 squared minus 4, A is 1, therefore C is 5. Then simplify 36 minus 20 is equal to 16. So the discriminant is equal to 16. So the discriminant is greater than 0 and it is a perfect square. Okay, because 16 is a perfect square, the square root of 16 is 4. Okay, so therefore, the roots are, if it's greater than 0 and it's a perfect square, the roots of the equation are real, unequal, and rational. Okay. So, rational. So, we will check if the roots are correct. So, by solving its solution and using the methods, one of the methods, which is if you are going to use that by completing the square, quadratic formula, or by factoring. Okay. So, this is our example, our given. 6x plus 5 equals 0. Okay. So, this time, I'm going to show you using quadratic formula. So, the quadratic formula is identify A, B, and C. And we know that the quadratic formula is equal to negative B plus minus square root of B squared minus 4AC over 2A. Okay? Then substitute the value of B, which is 6, plus minus square root of B squared is 6 squared. Okay. 6 squared, sorry with my writing, 4 times A is 1, then C is 5, over 2 times 1. Okay, and then negative 6 plus minus square root of 6 squared is 36 minus 20 over 2. Okay? Therefore, negative 6 plus minus square root of 26 minus, or rather 36 minus 20 is 16 over 2. And then, negative 6, since the square root of 16 is 4, therefore, we write 4 over 2. Then, find the solution or the roots using positive 4 over 2. So, we have Negative 6 plus 4 is equal to negative 2 over 2. Therefore, the root we have negative 1. And the other roots, we have negative 6 minus 4 over 2. So, x now is equal to negative 6 minus 4 is negative 10 over 2. So, therefore, x is equal to negative 5. Okay. So, we're going to check the roots now are negative 1 and negative 5. So, the discriminant tells us if d is greater than 0 and is a perfect square, the roots of the equation shall be real. Yes, so negative 1 and negative 5 are real numbers. Unequal, negative 1 is not equal to negative 5, and they are rational numbers. So, check. Okay? Another example. So, if we have 2x squared minus 4x plus 5 is equal to 0. Then identify A equals to 2, B is equal to negative 4, and C is equal to 5. Then plug in the formula for the discriminant, b squared minus 4ac. Then substitute b is negative 4 squared minus 4. Your a is 2. Your c is 5. Then negative 4 squared is 16 minus 8 times 5 is 40. Therefore, 16 minus 40 is negative 24. So therefore, the discriminant is less than 0. And if the discriminant is less than 0, it tells us that the roots of the quadratic equation are imaginary and unequal. Okay, so we are going to check na if it's imaginary or unequal. Okay, so we have 2x squared minus 4ax, 4x plus 5. So we're going to use the quadratic formula in finding the roots of the given equation. And we have the formula for quadratic equation using this method. Okay, negative b is negative. So negative b is 4 plus minus square root of b squared is negative 4 squared minus 4. A is 2 times c is 5 over 2 times a. This is 2. This is 2. Then we have negative times negative is positive. Plus minus square root of 4. Negative 4 squared is 16. Minus. So this is 40 over 4. So therefore, x equals 4 plus minus square root of negative 24 over 4. So, therefore, the roots are, so 4 plus minus, then get the factor of 24, negative 6 over 4. And then simplify. This is 4 plus minus. Square root of 4 is 2. Square root of negative 6 over 4. Therefore, the roots now are 4 divided by 4 is 1 plus minus 2 divided by 2 is 1. No need to write, and over 2. Okay, since this is in square root of a negative number, therefore it's an imaginary number. So we check that the result is an imaginary numbers and they are unequal. Okay? The other one is positive and negative, so they are unequal. Okay, next. If we have 5x squared minus x minus 2 equals 0, then a is equal to 5, b is equal to negative 1, c is equal to negative 2. So these are now the values of a. This is negative 1. This is 3. Okay? Then the discriminant now is b squared minus 4ac. So, substitute the value. B is 1 squared minus 4 times a is 5 times c is negative 2. So, we have 1 negative times negative is positive. 20 times 2 is 40. So, we have 1 plus 40 is 41. Positive 41. Therefore, the discriminant is greater than 0. Then 41 is not a perfect square. Therefore, the roots are, these are now the characteristic of the roots. If the discriminant is greater than 1, so they are real numbers and unequal. So, meaning unequal. And they are irrational. Okay? Okay, so we will check if these roots are correct. No? So, we have 5x squared minus x minus 2 is equal to 0. Using the quadratic formula, negative b plus minus square root of b squared minus 4ac over 2a. Okay, we will plug in the value. Negative b, your b is negative 1. Plus minus square root of negative 1 squared minus 4. Your a is 5. Your c is equal to negative 2. Okay? Over 2 times 5. Then negative times negative is positive 1 plus minus square root of negative 1 squared 1. Negative times negative is positive. So we have negative times negative positive 40 over 10. So therefore, D now, so we have now 1 plus minus square root of 41 over 10. So therefore, the roots are real numbers, unequal, and they are irrational because of square root of 41 is an irrational number. Okay? Okay, sige. So, the next example, you're going to determine the sum and the product of the roots. Okay? The sum of the products of the roots. As I just post this first.